Hi everybody, welcome to my channel Numbers with Nora. This is a math tutoring channel that helps you with all your math needs, math homework, any math questions you may have. This specific video is on Algebra 2, Polynomials, Functions Review Sheet, Part 2. I do have video Part 1 also on my channel, so check that one out. This one is just going to finish doing the sheet for polynomial functions review. Okay, so we're going to start on problem 6. All right, so for 6, it says suppose p of x equals 2x to the fourth plus 5x to the third plus 7x squared plus x minus 3. For question A, they want us to sit there and see what are all the possible roots for p of x. So we just want to list out all the possible roots. To do that, we have to do p over q, right? And our constant is going to be our p. And then the leading coefficient for our variable with the highest degree is going to be our q. And we just want to list out all the multiples of these, all right? So let's list out all the multiples of -3. It's going to be plus or minus 1. And then plus or minus 3. Those are all the multiples of my p. Now all the multiples of my q are going to be plus or minus 1. And then plus or minus 2. Now to list out all of our possible ones, we have to put these together, okay? Almost like a fraction wise. So 1 over 1 is going to be, well, plus or minus 1 over plus or minus 1 is just going to be plus or minus 1. And then this one plus or minus 1 over plus or minus 2, because we have to count for this 2 as well. It's going to be a fraction. It's going to be plus or minus 1 over 2. And then we do the same thing for this p. Plus or minus 3 over 1 is just plus or minus 3. And then plus or minus 3 over plus or minus 2. Again, that's going to be a fraction. Plus or minus 3 over 2. So that answers part A. And that's to say list all the possible rational roots for p of x. Okay. So now let's look at part B. Which of the possible rational roots are actually zeros of p of x? So now this is where we're going to use synthetic division and sit there and test all of these and sit there and see which ones using synthetic division does not give us a remainder of 0. All right. So I'm going to go ahead and erase this so I have more room. Oops. Just a second. I'll probably leave that bank of possible roots up here, so we can always refer back to it. Now, just for time's sake of the video, I did test some of these. I always start with positive and -1 and start with my easiest roots first. So for this one, I'm going to start with, if I do use synthetic division for +1, I'm not going to get a remainder of 0. So I'm going to sit there and start with -1. Like I said, I worked these out a little bit earlier. Okay. So with synthetic division, I assume that -1 is going to be one of my possible roots. And then I list out on this row all of my coefficients of my polynomial that they give me. The coefficient of my highest one is 2. Then I have 5. And then I have 7. Coefficient of this x is just 1. And I have -3. And you always want to sit there and make sure that your degrees are going down consecutively. So we have to the fourth, third, second, first, and constant. So I drop my first term down. That becomes 2. 2 times -1 is -2. 5 minus 2, that's going to give me +3. 3 times -1 is going to give me -3. 7 minus 3 is going to give me 4. 4 times -1 is going to give me -4. 1 plus -4 is going to give me -3. -3 times -1 is going to give me +3. And with my synthetic division, I have a remainder of 0. So then I know that one of my possible roots is going to be x equals -1. So that names one of my possible roots. And for this one, they want us to find all the roots of it. So since I already sat there and started synthetic division and found one of my possible roots, I can sit there and keep on going. All right. And so the new polynomial that I would write from this is simply going to be 2x. And since we already sat there and found one of our roots and did synthetic division, I go a degree lower, okay, and still use all of these as my coefficients. So a degree lower would be 2x to the third plus 3x squared plus 4x. And then minus 3. And that equals to 0. So we're trying to find all of our roots. All right, so I sit there and look and see if I can sit there and try to group this, or if there's something I can do to make this easier so I don't have to use synthetic division again. But I believe with this one, we are going to have to sit there and use synthetic division again. And we can't use grouping because if I did sit there and group my first 2 terms and my last 2 terms, I'm not going to be able to pull out something and have like matching binomials. So I am going to have to sit there and use synthetic division again. You could sit there and try, since we tried +1, that's not going to work. We tried -1, that worked. And like I said, I worked some of these out earlier. So the next one you could try is +1/2. And we're going to see that does work. So 1/2. And we use our synthetic division. And so I list out all my coefficients of this new polynomial. So I have 2 and 3 and 4. Oops, just a second. Then 4, then -3. So I drop this down. This becomes 2. 2 times 1/2, that just gets me 2/2, which is 1. 3 plus 1 is 4. 4 times 1/2 gives me 4/2. 4/2 is just 2. 4 plus 2, that's just going to give me 6. 6/2, that's going to give me 3. -3 plus 3 is going to give me 0, so that works. So I know another one of my roots are going to be x. Oops. Let's write it down here. X equals 1/2. All right. And then I can continue. And now I can write this as a new polynomial. And like I said, our last degree was 3. So I'm going to use these coefficients, and I'm going to go down 1 more degree. So now I have 2x to the third. Or sorry, to the second. Plus 4x. Plus 6 equals 0. I could go ahead and sit there and use the cross method of factoring, or I can notice that all of these have a 2 coefficient, or a 2 that I can pull out. So I can use greatest common factor, pull out a 2. When I do that, I just get x squared plus 2x plus 3 equals 0. I can go ahead and divide both sides by 2. Anything divided by, when I have 0 in the numerator, these cancel out. This just becomes 0. So now I have x squared plus 2x plus 3. And that's all in my parentheses right here after I sit there and divided both sides by 2. Now this looks like something we could factor. I want to find two things that multiply together to get me positive 3, but then add together to give me positive 2. I don't believe we can find something simple like that because 3 times 1 is 3, but there's no way I can add 3 and 1 to get 2 in any kind of way. So this one, we are going to have to sit there and use the quadratic formula. The quadratic formula is negative b plus or minus, negative b plus or minus square root b squared minus 4ac over 2a, just in case you forgot that formula. We are going to use this a lot with this sheet. Okay. And so I take my coefficients of here, my a coefficient, because this is the one that we're looking at here, that we're going to plug into that formula. My a is going to be equal to 1. My b is going to be equal to 2. And my c is going to be equal to 3. Okay. So now we just plug in the formula. So then I'm going to have negative 2 plus or minus square root my b squared, 2 squared, minus 4 times 1 times 3. I'm just using substitution. And then over, the whole thing is over 2a. 2, my a is equal to 1. Okay. I'm going to go ahead and simplify this down just for time's sake of the video. If you have problems simplifying this down using algebra, put something in the comments, and then I can sit there and show you step for step by this. But just for video time, I'm going to sit there and tell you what it comes out to. So when you simplify this down, this is going to become negative 2 plus or minus 2i square root of 2 over 2. Again, if you get lost from this step to this step, put something in the comments so I can sit there and show you step for step how we got here. All right. I can simplify this down even more by breaking apart my fraction. Negative 2 over 2 plus or minus 2i square root of 2 over 2. These two cancels out, and these twos cancel out. So then I can rewrite this as negative 1 plus or minus square root of 2. And I'll put the I behind that. Okay. So that's going to be another one of my roots. Okay. So these are all of my possible roots. X equals negative 1, x equals 1/2, and then x equals plus or minus or x equals -1 plus or minus square root of 2i. And notice I do have 4 roots because you want to have whatever your highest coefficient is, that's how many roots you're supposed to have. And this one, these are 2 roots because you have plus -1 plus square root of 2i and then -1 minus square root of 2i. So 1, 2, 3, 4 roots. Right? So that finishes 6. I'll give you guys time to copy that down because I'm going to have to do some erasing soon. And let's move on to these ones. Let me just do some erasing. Give myself some room. Okay. So now these ones, we're going to sit there and start solving. So again, we're going to sit there and use factoring. So for this one, right away, I can sit there and see I can do grouping, okay? Because there's 4 terms. It looks like I can pull out a greatest common factor. So when we do that, I can pull out a, right here, I can pull out an x squared. Oh, I see it now, but I want you guys to see why I can't do it. Because you will come around some questions like this. X minus 5 and then plus 2 in parentheses. And I have x. I believe that's plus 4. Notice I cannot sit there and continue because these 2 binomials are not the same. So that's not correct. Okay, I can't move forward with grouping. That's not going to work. So I have to sit there and approach this problem a different way. All right. So first, let's sit there and find out all of our possible roots for this polynomial. To do that, I identify my p and I identify my q. Okay. Just like we did with number 6. So all my possible roots, p over q. I list out all the multiples of 8, which is going to be plus and minus 1, plus and minus 2. Oops. In just a second. I had to plug in my computer. Okay. So plus and minus 2. Plus and minus 4. And then plus and minus 8. Okay, those are all the multiples of 8. And I do the same thing, but my leading coefficient for my highest exponent for my variable is going to be just 1. So down here is just going to be plus or minus 1. All right, so mostly all these p's are all my possible roots. So now I'm going to go on and sit there and try to test some of these. All right, so let's go ahead and try to test -1. When I try to test -1, I list down all my coefficients. So I have 1, -5, 2, and 8. I drop down this one. That's 1. 1 times -1 is -1. -5 plus -1 is -6. -6 times -1 is just 6. 6 plus 2 is 8. 8 times -1 is -8. And as we see, that works out. I get a 0. If you try 1, you're not going to get a remainder of 0. Okay. So I know one of my roots is x equals -1. Okay, and that's for A. So now I can sit there and rewrite my polynomial. Remember, with these coefficients now, I go down 1 degree. So now I have x squared minus 6x plus 8 equals 0. Now I can just use regular factoring. I want to sit there and think of two numbers that multiply together to give me 8, but add to get -6. Those two numbers are going to be -2 and -4. If I multiply -2 times -4, I'm going to get +8. If I add -2 plus -4, I'm going to get -6, right? So I can sit there and factor like this. I would have to use a cross method or something like that if there was a coefficient that's not equal to 1 right here, but that's not the case. So I can just use this regular factoring. So we said -2 and -4. And remember, to find my roots, I have to set both of these binomials equal to 0 and solve. If I set x minus 2 equal to 0, I add 2 to both sides, I get x equals 2. If I set x minus 4 equals 0, I have to add 4 to both sides, so then I get x equals 4. Okay. So those are all my answers for A. Those are all my roots. And when it says solve, it means like find all your roots. Okay. So now let's try B. All right. For B, we have 5x to the fourth minus 13x squared equals 6. First thing I want to do is bring everything to one side. This one's going to kind of relate to one that we did in the first video for this review sheet, where we had to do kind of like a U substitution. Okay. And I'll walk through this one again. I might walk through it a little fast. If you're not used to that U substitution that I did, then look at the first video I did on this, and I'll go in more detail. So all I did was like isolate it. So I have it equal to 0. I minus that 6 from both sides. Notice right here, I can rewrite this as 5. I'll try to do it in a different color. X squared squared minus 13 x squared, and then minus 6 equals 0. So I notice those x squares are kind of like messing it up for me. So why not write them differently? Let those x squares equal another variable so it doesn't throw us off, and we can sit there and deal with that at the end. Let it equal u. All right. So if we let those equal u, now I have 5. I'll do this in a different color again. U squared. All right, no, just u squared. Yep. Sorry, I already used the right colors. U squared minus 13, and then u. Okay, because we're anywhere where it says x squared, I'm just making it equal to u. And then minus 6 equals 0. Okay. Now this looks like something we can factor, something that we're used to. All right. So for this one, if I wanted to use cross method, it's going to be kind of hard to do, because then I have to think of two numbers that multiply together to give me -30, but then add together to give me -13. I can do 3 and 10, but there's no way I'm going to get negative 13 and then a negative 30 at the same time. So we're going to have to use the quadratic formula, okay? So again, I wrote the quadratic formula up there. If you need to see it again, pause the video or rewind and see it. So I have A equals 5. My B equals negative 13. And then my C equals negative 6. Right? So I plug this into my quadratic formula. I have negative 13. And then plus or minus square root of negative 13 squared minus 4 AC. A is 5. C is negative 6. Okay. And then over all of it is over 2A, which is 5. Again, if you want to see me sit there and use algebra to solve this all the way down, put something in the comments and I could show you each and every step. But just for time of the video's sake, I'm going to sit there and tell you what it's going to be. So this is going to be 13 plus or minus. And I believe that's 17 over 10. And this is a complex number. All right, I can sit there and solve this down even more. If I break it apart, I'll have 13 plus 17 over 10. Okay, and then I'll also have 13 minus 17 over 10. Right, so when I simplify this one down, I'm going to get 17 plus 13, that equals 30 over 10. Okay, 13 minus 17, that's going to give me negative 4 over 10. I sit there and solve these down. These zeros cross out. So I get, remember, we're using U. Okay. So I have U equals 3. And then I have U equals, because I'm just simplifying these down, negative 2 over 5. So remember we used a substitution. So now I have to set both my u's equal to x squared because that's what they're supposed to be equal to. So I'm going to do that over here. So I have x squared equals 3. I square root both sides. When I square root both sides, I have a plus or minus. So I have plus or minus root 3. And I do the same thing with my other u. I have x squared equals negative 2 over 5. And I have to square root these. So I have x equals plus or minus square root of negative 2 over square root of 5. But remember, we don't want to leave negatives under a square root, and I don't want to leave a square root in my denominator. So I can simplify this down even more. So I have x equals plus or minus square root of 2. I, because the square root of -1 is I. All right. And then over, I have to multiply the top and the bottom by square root of 5. All right. So I'll just get 5 at the bottom. Square root of 5 times square root of 2 is going to be 10. Again, for time's sake, if you want to sit there and get a little bit more detail what I did there, put something in the comments and I can show you step by step how I sat there and got that square root from out of the bottom of my denominator and brought it up top, and how I got that I. Oops, sorry, that's a different color. That's okay. I. Okay. So these are my 4 roots. Yep. And for B, of course, our highest coefficient is 4. So you know that we're going to have 4 roots. Okay. Now let's do C very quickly. Let me just erase. All right, so C is going to be a little bit easier than B. B was like one of the harder ones. So for C, let's go and factor. First, I want to get everything on one side. So I'll have 2x to the third plus x squared minus 8x, because I'm bringing everything to one side, minus 4. And that's equal to 0. Okay. Now this one's a little bit easier because now I'll be able to use grouping. My greatest common factor for my first binomial is x squared. What's left over is going to be 2x plus 1. And I pull out a -4. What's left over is going to be 2x plus 1. I know my grouping went well because both my binomials match. My inside binomials match. So I can rewrite this. My outer terms together are going to be x squared minus 4. And then my two matching terms I write as 2x plus 1. Now I want to sit there and solve for these, which means I want to find my roots. So I set each of my binomials equal to 0. For this one, remember, this is a difference of squares. So you can also write this as x plus 4 or plus 2. And then x minus 2. If you forgot about difference of squares, leave something in the comments, and I can answer that. And then I have 2x plus 1, which comes along for the ride. No, I set each and every one of these equal to 0. Oops. My pen is acting up. Equal to 0. So then I set this one, x plus 2 equal to 0. I just subtract 2 from both sides. X equals -2. I add 2 to both sides. X equals 2. I subtract 1 from both sides and I divide by 2. So x equals -1/2. And those are my my 3 possible solutions for C. Oops. Awesome. So that is that. If you have any questions on that one, how I did it, again, leave a comment. I'm going to go ahead and erase this. Actually, I don't need to erase that. Let's go down to 8. I'm only going to do some, or actually, let's do 8. And then if you have questions on 9, I can do that one in a separate video because I'm running out of time. So suppose that p of x is a cubic polynomial with roots 3i and -2, and the leading coefficient is 1. All right, this one is a little bit tricky, but it's not that bad. The one thing you need to know is whenever you have a complex root like this, just note that complex roots always occur in conjugate pairs, which means since I have a positive 3i, I know for a matter of fact, I'm also going to have a negative 3i as one of my roots. Okay. That's just a rule that's very important. Complex roots always occur in conjugate pairs. Okay. So you're going to have a positive one and you're going to have a negative one. All right. So now that I have my 3 roots, I can sit there and use this formula right here for polynomials. And this is how we write, we use this formula when we're writing polynomials when we're giving our roots, okay? So I'll have x minus my root, or I can write r sub 1 times x minus my r sub 2. And then x minus my r sub 3. And it just goes on and on from there, where your r's are just your roots that they give us. So this is where we're going to substitute in our roots. And I forgot as well, my apologies, that our a is right here as well. And we're going to substitute in our a. And our a is just basically, it's the degree of our polynomial. Okay. Yeah, so this one says cubic. So that gives us a hint what our a is going to be. A cubic is to the 3rd degree. So based on the information they gave us and this formula that we have for writing polynomials, we can go ahead and write out what our factored form is going to be. Okay, so our factored form is going to be p of x. Like I said, they gave us our a. Our a is what degree our polynomial is. They said it's a cubic. So a cubic is to the 3rd degree. Yes. Let me just make sure. Yeah, 3rd degree. Wait. Oh, my apologies. Our a is, something looked wrong. That's why. Sorry. So our a is actually, our coefficient is 1. Our a is actually our coefficient. So they give us that. My apologies. But it is going to be a cube root. So we know our x to the 3rd power is going to be our highest, and our coefficient is our a. Right? So in this case, our a is just going to be 1. All right, and I'll do this in a different color so you can see how I'm substituting this stuff in. So my coefficient right there, whatever is in black is part of our formula. So x minus, okay, let's do -2 first. So I substitute in that -2, okay, because I'm just putting it in place for my r's. Then I have x minus, next I have positive 3i. All right. And then I have x minus, then I have that -3i. And now I can just start simplifying down my formula. P of x equals, that 1 is just going to stay there. This will become x, simplifying down with inside my binomial, plus 2 x minus 3i, and then x plus 3i. Notice that looks like a difference of squares. So I can also rewrite this down as x plus 2 in parentheses, x squared, because we're writing this as a difference of squares, minus 9i squared. But then again, I can keep going because that I squared actually equals -1. Okay. So I have x plus 2. Sorry, I'm going to write over that 9 right there. X squared plus 9, because that I squared is actually equal to -1. Okay. -1 times -9 is +9. And that's going to be the answer to your factored version. Now, if you want to do B and write it in the standard form, all you're going to do is use FOIL and FOIL this out. Okay? If you want to see that, sit there and leave something in the comments. I'll send you a picture of step-by-step how that happens as well. Also, I'm running out of time. So if you want me to see me do number 9 as well, this one, again, leave something in the comments and I can get back to you and show you all the answers and how to work out number 9. Okay. And again, if you have any questions or concerns or any math help that you need, go ahead and subscribe or send me a comment. And I also offer math tutoring as well and other free math videos. Thank you, guys.